This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question AB6. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where it's appropriate, I will present some specific scoring examples. This free response question involves several functions, lots of letters, L'Hopital's rule, and even the squeeze theorem. The functions f, g, and h are twice differentiable, and g of 2 equals h of 2 equals 4. The line given here is tangent to both the graph of g at x equal 2 and the graph of h at x equal 2. In Part A, all we need to do is to find h prime of 2. In Part B, a new function a is defined, and we need to find both a prime of x and a prime of 2. In Part C, another new function h is defined. We know that the limit as x goes to 2 of h of x can be evaluated using L'Hopital's rule, and we need to use this fact to find f of 2 and f prime of 2. And in Part D, we're given an inequality involving g and h, and another involving a new function k. We need to determine whether k is continuous at x equal 2. Part A was worth 1 point, simply for the answer, 2/3. Part B was worth 3 points. The first point was for the general form of the product rule, necessary to find a prime of x. The second point was for the correct expression for a prime of x. And the third point was for the value a prime of 2. Part C was worth 4 points, and there's a lot written on the scoring guidelines. The first point was for recognizing or connecting this limit to h of 2 equal to 4, because h is continuous. The second point was for finding the value of f of 2. The third point was for using L'Hopital's rule. And the fourth point was for finding the value of f prime of 2. Part D was worth 1 point, and there were a lot of little things necessary here to earn this point. But generally, we need to see that the student concludes that k is continuous, and that they provide sufficient justification for this conclusion. Here are some general comments about student performance on this question. In Part A, most students recognize that h prime of 2 is the slope of the tangent line to the graph of y equal h of x at x equal 2, and therefore most students reported h prime of 2 is equal to 2/3. However, the most common error was h prime of 2 equal 4, the y-intercept of the tangent line. In Part B, most students knew that in order to find a prime of x, they needed to use the product rule. However, the most common mistakes here included copy errors, parentheses errors, and an incorrect derivative of 3x cubed. Now, most students knew that they needed to evaluate a prime of 2, but unfortunately there were several simplification errors. Remember that students don't need to simplify a final numerical answer on the AP Calculus exam. In Part C, few students indicated that h is continuous at x equal 2. And many students did not connect the limit as x goes to 2 of h of x to h of 2 equal 4. Now, most students understood that they needed to use L'Hopital's rule, but there were some errors in derivatives. Many students were able to find the correct value of f of 2, but fewer were able to find the value for f prime of 2. And the most common error here was with notation. In Part D, few students presented a complete justification in order to earn the single point in this part. The most common errors here included the failure to mention that g and h are continuous, no discussion of the limit as x goes to 2 of k of x, and the use of an incorrect theorem, for example the mean value theorem or the intermediate value theorem. Now let's take a more careful look at the scoring guidelines. Part A was worth 1 point, simply for the answer. And this had to be our answer 2/3. In this part of the problem, the 2/3 could be presented unsupported or unlabeled, and the student would still earn the point. If the 2/3 was included only as part of a tangent line equation, then the 2/3, had to be boxed or circled or highlighted in some way. If the student wrote y prime is equal to 2/3, that was okay, and it earned the point. And the most common student error here was to identify the y-intercept as part of the tangent line equation as the derivative. So some students incorrectly wrote h prime of 2 is equal to 4. Part B was worth 3 points. Students had to find both a prime of x and a prime of 2. In order to find a prime of x, students needed to use the product rule. So the first point here was sort of a concept point for demonstrating the general correct form of the product rule. Now the expression presented does not need to be labeled here as a prime of x. However, the expression must be in this form, where p of x and q of x are polynomials. And form of the product rule means there must be a sum of two terms, and h of x must be part of one term, and h prime of x must be part of the other term, and both h of x and h prime of x must be multiplied by polynomials. The second point in Part B was for the correct expression for a prime of x. Now again, this expression does not need to be labeled. And here's a common correct alternate form presented by many students. Here are some example student responses and how each was scored. In example 1, there is no sum of two terms. This response does not earn the first point and is not eligible for the second or the third. In example 2, the form of the product rule is correct, but the 3x squared term is incorrect. This earns the first point, not the second, but is eligible for the third. In example 3, the form is incorrect, so this doesn't earn the first or the second point and is not eligible for the third point. And in example 4, the form is correct, but one of the terms is incorrect. So this earns the first point, not the second, but is eligible for the third point. The third point in Part B was for the value a prime of 2. And there was an eligibility criteria here. The student must have earned the first point, the form of the product rule point. Now, there was an exception if the student used the tangent line expression for h of x, and we had a very fair way to score this solution. If a prime of x was incorrect, but it was of the correct form, then we read with the student for a consistent answer. If h prime of 2 was incorrect imported from Part A, then we also read for a correct answer. However, if the student wrote a prime of x is equal to a prime of 2, they did not earn this point. This was considered a linkage error, or bluntly, just bad notation. And there were many unsimplified forms of the final numerical answer presented by students, which was okay. Here are some example student responses and how each was scored. In example 1, the student has the correct product rule form, but they made an error. The 6x squared is wrong. But they're still eligible for the third point. And they found their a prime of 2 correctly, so this earns 101. In example 2, correct form, incorrect derivative, correct a prime of 2. So this also earns 101. And very briefly, here are some other common errors. If the student imported an incorrect h prime of 2 from part A, they were still eligible for all 3 points in part B. For example, if they used h prime of 2 equal 4, the y-intercept of the tangent line, then a prime of 2 is equal to 240. And unfortunately, there were some arithmetic errors in evaluating a prime of 2. Part C was worth 4 points, and there was a lot to do here. The first point was for equating this limit to 4. Now, this expression often appeared late in the student's solution, and that's okay. In fact, it can appear after applying L'Hopital's rule. The expression didn't have to be the first item presented. But somehow, to earn this point, the student had to connect this limit to 4, or show a correct evaluation of the limit in some way. And in finding this limit, the student did not need to mention that h of x is continuous. Here are some example student responses focusing on the first point and how each was scored. In example 1, here's a very simple way for the student to earn the first point. In example 2, the student has conveyed the connection and demonstrated L'Hopital's rule. So this actually earns the first and third points. In example 3, the student has made the connection for the first point, but that's it so far. And notice that there is no limit symbol here. In example 4, there is an error in the derivative of the denominator. So the student has conveyed L'Hopital's rule, point 3, but not the first or limit point. In example 5, the limit point is not conveyed, and in example 6, similarly, the limit point is not conveyed. The second point in part C was for the value of f of 2. Now, there were no bald answers accepted here. There had to be supporting work. And the philosophy in scoring this part is that we need to see the denominator set equal to 0. The student does not need to mention L'Hopital's rule to earn this point. And the answer must be ours, f of 2 equal 1. Here are some more example student responses, this time focused on the second point and how each was scored. In example 1, the denominator of h is set equal to 0. We see the correct value of f of 2, so this earns the point. In example 2, this is just another way to convey the denominator set equal to 0. We see the correct value, so this also earns the point. In example 3, that's not the denominator set equal to 0. So even though f of 2 is correct, this does not earn the point. And in example 4, similarly, we have a wrong expression set equal to 0. So this does not earn the point. The third point in part C was for sufficiently demonstrating the use of L'Hopital's rule. And just a little bit about notation here. If a student writes this limit is equal to 0 over 0, then they do not earn the third point, regardless of what follows. However, these expressions, with arrows or no symbol, are okay. So, for now, students cannot write that a limit is equal to 0 over 0 on the AP Calculus exam. Here's the philosophy behind scoring this point. We need to see a limit of a quotient of derivatives. And that means we need to see a limit and a quotient and be convinced that differentiation was attempted by seeing f prime of x in the denominator. And finally, the last point in Part C was for the value of f prime of 2. And there was an eligibility criteria here also. The student must have earned the third point, unless the quotient was correct but the limit notation was missing, or the notation used was incorrect. And the answer must be our answer, and the student cannot import an incorrect f of 2. Here are even more example student responses, this time focused on the third and fourth points and how each was scored. In example 1, I can see L'Hopital's rule here, that's the third point, and the student is eligible for the fourth. In example 2, I can also see L'Hopital's rule, but there's an error in the denominator. This earns the third point, but is not eligible for the fourth. The student cannot get the correct answer. In example 3, I can see L'Hopital's rule in the denominator. So this earns the third point, but not the fourth. In example 4, there is no limit notation. This does not earn the third point, but is eligible for the fourth. In example 5, there is no limit notation. The derivative in the denominator is incorrect. So this does not earn the third or the fourth point. And in example 6, the student has used bad notation. So they don't earn the third point, but they could go on to earn the fourth. Part D was worth 1 point for concluding that k is continuous at x equal 2, and for presenting sufficient justification for this conclusion. Now, here are some alternate names for the squeeze theorem that were accepted. Now, I'm not sure who's teaching the fly-swatter theorem, but we accepted it. And here are some theorem names that were not accepted in Part D. Here is a list of items that we needed to see in order for the student to earn this point. First, the student must conclude and answer yes that k is continuous. And for justification, they must state that both g and h are continuous. And they must also conclude that both of these limits are 4. And therefore, the limit as x goes to 2 of k of x is equal to 4 also. And finally, they must state that k of 2 is equal to 4 because g of 2 and h of 2 are 4. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there's also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.